This video is part of the Introduction to Data Analysis with R screencast series produced by the Chair of Political Methodology at the Political Science Department of the University of Zurich. This is the second episode in the first series and it is about variables and functions. But the first thing I will do in this episode is source the file that I created during the last episode. While this is not strictly necessary, it illustrates how to source files in RStudio. The first thing is to open the file in the RStudio editor. Here I use the shortcut Ctrl-O, and then I choose the file. When the file is open, I click on the small caret symbol next to the source button in the editor pane. This opens a drop-down menu with two options. If I click Source, R executes all the commands but does not show this in the console. Here I want to see the result of the commands I source. Therefore, I click on the second option. As you can see, this makes R print all commands and their result to the console. If you downloaded the material for this episode, you saw that there is another script file included. I open the script file again using the shortcut Ctrl-O. This script file contains all the commands that I will use during this episode. Each step has a short annotation. All future episodes will have such an accompanying script file. And from now on, I will copy commands from the script file rather than type them by hand. This can be done conveniently by highlighting the commands I want to run and then clicking the Run button, or by using the shortcut Ctrl-Enter. After the brief introduction to script files and sourcing, we come to the first main topic of this episode: variables. Variables were introduced during the last episode. I explained that I can store the result of any R expression in a variable. For the first variable, I chose the generic name A. In general, variable names in R can contain the letters A to Z, numbers, and also underscores and periods. These elements can be combined freely to make names, but there are two restrictions. A variable name must not start with either a number or an underscore. The first three assignments are valid, but the next two assignments are invalid because of the restriction. The restriction does, however, not apply to periods. When I create new variables, I want their names to be short but nevertheless meaningful. But often, meaningful names are quite long, which is unpractical because I have to type the same long variable name over and over. However, RStudio has a convenient feature to help you when you have long variable names: tab completion. When I have a very long name and want to use the variable, I can start to type the first few characters of the variable name and then hit the tab key. A drop-down menu opens, listing all functions and variables that start with the given characters. I can then hit Enter to insert the highlighted completion. If the completion is unique, the only possible completion is inserted direct. Tab completion works on almost anything, for example functions, function arguments, files, and of course variables. An additional property of variables is that you can redefine them in place. That is, the same variable can be used on the right and on the left-hand side of an assignment. Also, variables return the assigned value upon creation, so you can chain variable assignment like in this example. Naturally coupled with variables are functions. Whereas variables are used to store results, functions use variables to generate results. Functions are used to achieve everything, from reading data from a source file over recoding values of data to estimating a statistical model. To start, I look at a simple mathematical function, the logarithm. The logarithm function is called log, as you can see in the script file. But if you didn't know this, another RStudio feature becomes handy: the integrated help browser. You can either click in the search field of the help panel and search there, or you can type a question mark followed by the search in the console. When you type one question mark, R searches just the names of functions. So this works well when you already know the name of the function. But if you don't know it, you can type 2 question marks. This way, R also searches the body of all the help files and presents a list of matches. Now let's have a look at the help file of the logarithm function. The structure of these files is always the same. It starts with a title and a short description. Then follows the definition of the function and a short description of which arguments the function takes. Additional information is in the details part. The value which the function returns is under value. Then follows additional information which for now is not relevant. At the end of the help file is again interesting information. See also informs about similar functions, and the example section shows how the function is commonly used. When we look at the examples, we see some basics about functions. To use a function, you type the function name, followed by an open and close parenthesis. Inside the parentheses are the arguments of the function. The provided examples only have one argument each, but many functions will have more than one argument. There are also functions without any arguments. If I go back up in the help file, I see that the log function takes 2 arguments. X is the value which one wants to compute the logarithm of, and base is the base with respect to which the logarithm is computed. Furthermore, there is a default value for the argument base. This means that if one does not supply an argument base, R uses the default value exponent 1. So when you type log x equals 100, R uses base equals x1 by default. It also means that the base argument can be left out and the function will still work. However, if you leave out an argument without default, R returns an error. I can verify that the default value is used by explicitly supplying the argument base with the default value. I can also change the argument to another value, for example 10. You can also abbreviate the names of the arguments as long as they remain unique. Here only the letter B suffices, because the only other argument to the function starts with the letter X. In the previous commands, both arguments were set by name. That is, I first put the argument name, followed by an equality sign and the value of the argument. It is also possible to set arguments by position. Then you can leave out the argument name, but you have to follow the right order, which is determined by the function definition. So the above command can be shortened, but the order of the arguments has to match the function definition. So this is something else than the commands before. But if you again supply the argument names, the order of the arguments does not matter. Most functions in R have arguments without and arguments with default values. The arguments without default values are almost always among the first arguments in the function definition. This makes it easy to specify them by positional arguments. Such arguments are mostly the data on which a function operates, as in the R example with the log function. Arguments with a default value are often options that change the function behavior. Because you often do not specify them in the right order, you have to use the names of the arguments. This may sound complicated at first, but you will get used to the logic just by looking at the R code that comes with this introduction. One important thing to remember is that, regardless of the number of arguments and how you specify them, you must never omit the parentheses. Take for example the function options. It can be called without any arguments. But if the parentheses are omitted, R does not execute the function. Instead, R just returns the function's definition. To execute the function, one has to add empty parentheses. This way R calls the function and returns the result. As you might have guessed, options shows the values of all options that can be set in R. This last important comment marks the end of this episode. I covered sourcing R script files, defining variables, using functions, and specifying function arguments. The next episode will be about data types and data containers.